In this video we're going to look at the role of a, and we see that a is greater than 1 here, but we're also going to consider a to the minus x. This is our increasing function and this is our decreasing function. Again, a is greater than 1. Remember, we rewrote this one, type 2, where a is a fraction. We rewrote it as this new function a to the minus x. Type A, where we have a to the plus x and a is greater than 1, is an increasing function, and type 2, which is a to the minus x, is a decreasing function, although a is still greater than 1. I'm using the green graph, f of x equal to 2 to the x, as my mother graph, and depending on the value of that a there, we will also have other mother graphs, but in this case we will use the 2 to the x as our mother graph. We can always work out 2 to the something, so we have a domain of r, but our answers will always be greater than 0, so it's everything from 0 up to infinity, but not equal to 0 and never negative. We never have an x-intercept for this graph, but the y-intercept occurs when x is equal to 0, and that will be 1. You see, it cuts the y-axis at the point 1, and that is our y-intercept, and the x-axis here, that is our horizontal asymptote. And although this graph goes up, it never have a vertical asymptote for an exponential function. It just keeps on increasing up to infinity. Now I've taken my a and I've increased it to 3. From 2, I increase it to 3. And my domain will still be all real numbers. And my range will again be from 0 to plus infinity. Y cannot be 0, so we do not have any x-intercept. So there's no x-intercept. The y-intercept is when x is equal to 0, so we must substitute into that 3 to the x, I must substitute 0, and that will give me a value of plus 1. And that is exactly what happens there. You see there's the blue graph, and again no vertical asymptote, but the horizontal asymptote is exactly the same as before. That is the line y equal to 0 or the x-axis. What I want you to notice here is this. Both the y equal to 2 to the x and y equal to 3 to the x have a y-intercept of 1 at x equal to 0. On the right hand side, when x is positive, when x is greater than 0, then the blue graph will be above the green graph. So y of b will be greater than y of a, but on the left hand side the green graph is above the blue graph. If I look at minus 1, if I say what is 2 to the minus 1, that is a half, but what is 3 to the minus 1, that is a third. And most definitely a half is greater than a third. So that's why the blue graph is now below the green graph. I've added a red graph and a purple graph on that same set of axes that we had before. The red graph is now 4 to the x. Remember, previously we had our green graph and our blue graph. The green graph y equal to 2 to the x and the blue graph y equal to 3 to the x. The smaller the graph, the smaller the value of the graph will be. The red graph is h of x equal to 4 to the x. Note that we have 4 is greater than 3 is greater than 2. So on first of all, the domain is still R and the range is exactly the same. Again, we have no x-intercept, and the y-intercept will be 4 to the 0, which is also 1. So again, it goes through the same point there. There's no vertical asymptote, and the horizontal asymptote will be also y equal to 0 or the x-axis. And the same for the purple graph, which is a much bigger a value, 10. We have the domain, the real number. We have the range from 0 to infinity. We have no x-intercept, but we have a y-intercept at 10 to the 0, which is also 1. And we have a horizontal asymptote of y equal to 0, which is again the x-axis. Again, if I look here on the graph, I will notice that for x greater than 0, the y to the 2x is smaller than y to the 3x is smaller than y equal to 4 to the power of x. This is y equal to 10 to the x, the purple one. That's on the right hand side. So the larger the a is, the higher the graph goes on the right hand side. At x equal to 0, they all go through the point 0, 1. And on the left hand side, the larger the a is, the smaller the value of the graph will be. The y values at the respective points G, F, E and D is given by G will be 1 over 10. And F will be 1 over 4, and E will be 1 over 3, whereas D is 1 over 2. So that is less than that. Although they are all positive, whenever x is negative, the large A will be below this 2 to the x, which we took as a mother graph here. On this page, the end of that file, you will just see an illustration where x is equal to 0. When x is greater than 0, then we have all these values. And when x is negative, then we have this situation. So please remember that the one is not always greater than the other one, depending on our value of x. It will sometimes be below the other one.